Good to see you all back. I hope you are all doing safe and happy to see you back to learn your content. Let me share my screen. Yes, in continuation with the previous one, actually, you may be new to this particular topic. We were discussing about our measurements related to instrumentation gate syllabus in previous classes, and some of you might have attended the same. And today's class, we would like to see something relevant to measurements. So, our major scope here is the measurements. So, that is the topic. Is the screen visible? Please, someone respond.
Yes, sir.
Yeah, thank you. Have you studied this subject before? Measurement and instrumentation, or measurement?
Yes, sir.
Good. So you know what is measurement, right? So how do we measure? So there are a little bit theory behind in each and every content. So first let me take some time to discuss a theory related to this measurement. So first thing is, how do we measure? See, if you don't feel comfortable when you are not feeling well, which means we have a system. Let me take our physical system as it is. We are a human being. This is our system. Our system is connected together. That is, various parts are connected together. Generally, we take a human being, various parts are connected together. Those various parts may have, like, your brain, I'm sorry, your brain, your heart, right? You may have your stomach or functionalities like kidneys. So let me take a few for as an example. So first one is brain. This is a processor which will process the given input. Right. Second one is your heart. This is a pump which will pump blood. A kidney, which is a machine which will eliminate unwanted particles available in the blood. So these are all the various parts, equipments we can say. So these equipments which helps to function your entire human system. So let me take it as a human system. So this human system is taking some input, This input may be the food, water, right, air. So all these things that we are consuming, no, that is what the raw material we call it as an input. So that will provide you an energy to give you the output. Right, those outputs are in terms of mechanical energy. Sometimes it may be in terms of electrical energy. Right, your brain, which will induce some electrical systems in your body, no, so that we call it as an electrical energy. Sometimes you may pick some material, you may place it to some other point, which we call it as a mechanical energy. So we are taking input, no, those inputs are the raw material, as I said. One is your food, another one is your liquid, that is water, that is solid, liquid, and air. These three medium we are intaking. So up to this, we are all very much knowing. So this is not a problem right now. Now what happens? Some external particles, as I said, if any virus induced to you, what happens? சொல்லுங்க பார்க்கலாம். உங்க உடம்புல ஒரு சின்னதா வைரஸ் வந்ததுன்னா என்ன ஆகும்? ஃபர்ஸ்ட் ஜாலியா பேசலாம், நோ இஷ்யூஸ். I do not have any restrictions. What happens if any virus induced to you? Any guess? What is the first reaction you will get in your body? There will
Temperature
be,
increase, sir.
very good, there will be a rise in temperature. ஸோ டெம்பரேச்சர் வந்தோடனே நமக்கு ஒரு பயம் வந்துடும் இல்லையா? என்ன இருக்கும்? ஒருவேளை will it be COVID or will it be Omicron? ஒரு பயம் வந்துடும் இல்லையா? இந்த பயம் என்ன பண்ணும்? நம்ம உடம்புல இன்னொன்று ரைஸ் பண்ணி விட்டுரும். என்னது? The fear that created in your brain will induce something else. Temperature ரைஸ் ஆகிடும். நெக்ஸ்ட் என்ன ரைஸ் ஆகும்? ஒரு பயம் வந்துச்சுன்னா, ஒரு படபடப்பு, ஒரு ஃபியர், ஒரு த்ரெட், ஒரு ஸ்கேர், if it is induced in your body, what happens? படபடன்னு வந்தோடனே எப்படி இருக்கும்? Which will increase?
Sweat ஆகும், sir.
Sweat ஆகும். Pressure will increase. இப்போ டெம்பரேச்சர் இன்க்ரீஸ் ஆயிடுச்சு, ப்ரெஷர் இன்க்ரீஸ் ஆயிடுச்சு. It will also increase your humidity. ஸ்வெட் ஆயிடும். ஹியூமிடிட்டி இன்க்ரீஸ் ஆயிடுச்சு. ஸோ ப்ரெஷர், டெம்பரேச்சர், ஹியூமிடிட்டி. அப்போ உங்க ஹார்ட் ரேட் எப்படி இருக்கும்? எஸ், ஹார்ட் ரேட் எப்படி இருக்கும்? கம்மியா இருக்குமா அதிகமா இருக்குமா? Blood flow will also increase. That's it. இந்த parameter தான் we are studying in instrumentation. Temperature, pressure, flow, humidity, and one more thing is we will also have it as level. So here in our human body we do not have any level. It's level in the sense a water level in the tank. Like நம்ம பாடியில அந்த மாதிரி லெவலுங்கிறது it is like your body is consisting of around 73% water. That is what the level. அப்ப என்ன ஆகும்னா the water level will be reduced because we will be taking so much of tablets. Right? அப்ப என்ன ஆகும்னா நம்மளுடைய level change in level which will occur here. The level will not be increased, but it will have a good impact. The level, the water level, sometimes hemoglobin levels are reduced. So we as a human being do have certain parameters like temperature, pressure, flow, humidity, and level, and the same thing which is applicable for any physical system. Any physical system, if you take, these parameters will have a good impact. So, well, if my physical system, if my human body should run in a proper way, என்னுடைய சிஸ்டம் ப்ராப்பரா ரன் ஆயிட்டு இருக்கணும், எந்த டிஸ்டர்பன்ஸும் இருக்கக்கூடாது. ஐ ஷுட் ஸ்டார்ட் மை டே இயர்லி இன் த மார்னிங். இட் கேன் பி 5 AM, no issues. It can be 4 AM. Sir, I am not that much great. I'll wake up only at 10 AM, no issues. Wake up at 10 AM. Those who are getting up 4 AM may sleep at 9 PM at the maximum, or 10 PM. So if you are getting up by 10 AM, you may go to sleep around 12 PM or maybe 1 PM. So it depends. Your cycle, when you get up, you do your functionalities and you go to sleep, and it will be repeated. It will be repeated. So it will be repeated. Look at here. If you don't mind about your sleeping time from 12 PM to 10 AM, that is early morning, if you are not worried about your sleepiness, நீங்க எப்போ தூங்கினாலும் அடுத்த நாள் 10 மணிக்கு தான் எழுந்திருப்பேன். நான் 12 மணிக்கு தூங்கினாலும் 10 மணிக்கு தான் எழுந்திருச்சுப்பேன். 3 மணிக்கு தூங்கினாலும் 10 மணிக்கு தான் எழுந்திருச்சுப்பேன். 4 மணிக்கு தூங்கினாலும் 10 மணிக்கு தான் எழுந்திருச்சுப்பேன். I will not be worried about my sleep time in between, which means the system is open loop system. Please be careful about this. You are getting up, you are doing your functionalities, you are not worried about these functionalities, you are not worried about the outcome. You will go to bed once again, you will get up and you will continue whatever you do. But some people will have a system which is a feedback. What they do, they will get up, they will have a task. So today's date is 21/1/22. So inniki we have to learn something relevant to measurement. So in this we have to complete minimum 5 questions. This is related to academic. Sir, academic goals are living. We should watch 2 movies at least. We should watch 2 movies. எழுந்திரிச்சிட்டோம் 10 மணிக்கு எழுந்திரிச்சிருக்கிறோம். We will eat something. We will be lazy enough to switch on all your components, notifying your WhatsApp, Insta, and other things. Have your lunch and watch movies. And you are bored with one movie. You could not able to watch the second movie. What you do? When you go to bed, you will give the constraint like இன்னைக்கு நம்ம 2 target வச்சோம். We finished one. The next one we should finish by tomorrow. So we are taking the feedback about the process of that particular time, and we are taking the feedback. We will watch the second movie tomorrow and we will complete. So if you take the feedback and if you respond to those input, you will be called as closed loop. So this is applicable for any system, not only for human being. It is applicable for any system. அப்போ எந்த ஒரு சிஸ்டம்னாலும் we need to either go to open loop or closed loop. Here we are taking the input. No, என்னுடைய number of movies 2 or 1 which we are measuring. No, that is what comes under measurement, right? So your target is 2 and you have done only 1. You are doing the calculation measurements, no? That is what measurements. So this is an example I told. So similar to this, you see, as a physical system, as a human being, your body is functioning properly. So when my body is functioning properly, the parameter that is to be in that particular range are temperature, pressure, humidity, flow, and certain parameters related to the level like hemoglobin, water, oxygen, and other things. So I have to maintain all these things. So if there is change in the temperature, so I may be infected by COVID or I may not be. That is not a matter. Whatever the thing. See, I am not feeling good today. I have some throat infection. My nose are like locked because of the climatic conditions. So this is quite natural. Your body will react. So the climate should be adapted to your physical system. So what it do, it will just create a cold infection within you. அதுக்குள்ள clear ஆகல, the infection is little bit severe. So by the time what it do, உங்களுக்குள்ள இன்டியூஸ் ஆன வைரஸை டெலீட் பண்றதுக்காக தான் டெம்பரேச்சர் ரைஸ் ஆகுது, right? The temperature will be raised. So we have to measure this parameter, no? So how much infection, that is what this matter. If I have only one virus, my normal temperature is around 97 to 98. So by this range I will not be worried. When it crashes 98, I'll be little bit worried. When it reaches 99, I'll be much more worried. When it reaches 100, I'll be little more worried. Right. So this worrying factor, why we are worried with this temperature? When the temperature increases, which means the input, that is the unwanted particle, is not removed by this particular temperature. So your process is increasing its own temperature so that it can try to kill the virus. And it goes 101, 102. So how do we measure all these things? In your body temperature, we measure control. How do we measure? We will be measuring by means of either we will be measuring by means of either sensor or transducer. So I need to measure that particular parameter, whether it is temperature, humidity, level, whatever it is, those details are to be measured by means of sensors and transducer. Now, we are not going to target on these sensors and transducer. We are going to target how to measure the information through this or maybe without this. How do we measure? So நமக்கு தெரிஞ்சது measurements, the sensors and transducers are used to measure the physical quantity. The physical quantity. But when it is pressure, when it is temperature, we cannot easily go with the pressure temperature directly. We have to go with only the electrical measurement. That is, I need to get the information in terms of electrical quantity. So that is what we are going to check. When it is an electrical quantity, you see, even if there is a temperature rise in your body, we will be using some sensors. No, that sensor is connected with a resistor. That resistor will change itself for the given temperature. அப்போ என்னுடைய temperature change ஆச்சுன்னா resistor value என்ன ஆகும்? It will be decreased. When the temperature, see, I am talking about the resistor. Resistor positive coefficient. So temperature rise ஆயிடுச்சுன்னா என்ன ஆகணும்? Conductivity எனக்கு increase ஆகணும். So that is what we are going to check. So the electrical quantity is what the measurement that I am going to do. When I do electrical quantity, there are certain things that I should know. One is V, another one is I. So this V stands for voltage and this I stands for current. And beyond this, we may have combination of this power, which is power. Power is equal to V into I. This is also we know. And when I have voltage, current, power, I may also have, right, the relevant equipments I may use. No, excuse me. V voltage, I current, P power, and there are some components I will be using to measure this voltage, current, power. No, so those components are resistor. Major component is, give me 1 second. Major component is resistor. Right. Sometimes we may also use inductor, we may also use capacitor in your circuit. But here, I don't want to force you to learn lot more things. Let us directly go with these components alone. Voltage, current, and power measurement. Right. These three alone we are going to work on. I think we will be ending only with these three parameters. So no need to worry much about these things. Right. We'll go directly. So when it is a current, what happens? Let me tell you. How do we measure? When it is a current, we will be measuring. Sorry. We can use some instruments. No, the first one is. Let me take. First one, the ammeter. This is the first measurement. We will be using ammeter. நிறையெல்லாம் யூஸ் பண்ண மாட்டோம். டைரக்டாக எடுத்த உடனே we will not be going with like digital multimeter and all. We will be going one by one. The first one is ammeter. So ammeter is the instrument. You may have noticed that this ammeter, எப்படி இருக்கும்னா, it may be in terms of box, right? Here you will have a needle. So this needle is connected in this point, which will be standing at zero initial condition. And if your instrument is capable enough to measure 5 amps at the maximum, the current will be measured in terms of amps. So if the range is 0 to 5 amps, the minimum value is 0, the maximum deflection I can get is 5. Right. So here comes your first testing. Here comes your first testing. Okay. So let me go with my first question with respect to this ammeter. One second, let me take the question for you. So let us have the first question. Ammeter ammeter is used to measure current range from 0 to 5 amps. 0 to 5 amps. And it has minimum resolution of minimum resolution of zero point 0.2 amps. So find the number of divisions. Find the number of divisions. It is a direct questions. It is a direct question. Try to find it. So it's a direct questions. Look at here. I have an ammeter. So the needle deflection which starts at 0 and my maximum value is 5. So I have certain measurement. No? So here it will be 2.5. Right. So this deflection I am going to consider, and they told it like the minimum resolution is zero point 0.2, which means the adjacent measuring identity we have in our ammeter now, the range between these two is zero point 0.2. So zero point 0.2, zero point 0.4, zero point 0.6, zero point 0.8, and 1. 1.2, 1.3, 1.6, 1.8, 2, 2.2, 2.4, 6, 8, 3, 3.2, 3.4, 3.6, 3.8, 4, 4.2, 4.3, 4.5, 4.6, 4.8, and 5. Now you tell me how many number of divisions available. 1, 2, 3, 4, 5. So, which means my maximum measurement is 5, sorry, maximum measurement is 5 amps, and my minimum measurement is zero point 0.2 amps. Amps cancel. So, this is likely to be what? Zero point 0.5, sorry, 5 divided by zero point 0.2, which is equal to, so you may get it like, right? So, this is like 5 divided by zero point 0.2 is equal to 2 divided by 10. So this is like 50 divided by 2. So you'll get it like 25. So number of divisions will be 25. So this is what? How did we take? We have taken it now. The maximum value that I can measure, the maximum value I can measure divided by the minimum value I can measure. So which will tell you the number of divisions. And to this notification, there are something we should know about this particular instrument. Not only this particular instrument, for any instrument we are measuring now that we have to consider, right? So let me tell you those in. parameters. The first one is full scale value. So note down the first one, we call it as full scale value, that we represent as FSV. Full scale value in the sense, if you have your instrument like this, on measurement we are making, the measurement can be temperature, pressure, humidity, level, energy, power, whatever it is. The full scale deviation will give you one reading, no, that is what the full scale value, right? If the second one, accuracy. See, these are all the relevant parameter we will be getting to in our gate. Okay, accuracy. So if I am giving you 2 degrees Celsius change in my body is giving 36 degrees Celsius as my measurement. There is a change in 2 degrees. It's supposed to be 38 degree, but your instrument may give you only 37.9 degree. So measurement will be with respect to the accuracy of the instrument. My measuring accuracy is different. So when accuracy is less, there will be some deviation. So this is what accuracy. So my instrument will have certain accuracy. எவ்வளோ அக்யூரேட்டா ரிசல்ட் தருதுன்னு சொல்லுவாங்க இல்லையா, that is what accuracy. We have to note it down. Third one, error. For any lab experiment, for any measurement we are doing, might be when you go to your lab, your instrument will have a needle, no, that will not be standing at zero. Look at here, this will not be standing at zero. Sometimes the needle will be standing at zero point 0.2. So what you do, you will take your measurement, you will take your actual measurement, you will take your initial reading, that is at zero condition, you will take your reading. What you do, the real value will be your measured value minus initial reading. So that will what? Your real value. So these kind of errors which may be available, that is initial condition error which may be appeared. Sometimes what I do, my accuracy is less. So my instrument, if it say 10 amps, if it says 10 amps, this will not be 10 amps exactly. The variation may be, the value may be 9.8 amps to 10.2 amps. This may be the difference. So how much difference I am getting? That they will be taking it in terms of percentage error. Percentage error. Right? So whatever the reading that you take, there will be some error in my reading. I myself will accept. நான் இன்னைக்கு நடத்திட்டு இருக்கிறேன், நான் உங்களுக்கு ஒரு 5 ப்ராப்ளம் நடத்துறேன். அந்த 5 ப்ராப்ளம்ல ஐ மே ஹாவ் சம் மைன்யூட் எரர், லைக் நான் உங்ககிட்ட சொல்லலாம் 8.46 இஸ் த வேல்யூ, பட் யூ மைட் ஹவ் காட் இட் லைக் 8.45. ஸ்மால் டீவியேஷன் இருக்கு இல்லையா, திஸ் இஸ் த எரர் பிட்வீன் யூ அண்ட் மீ. Maybe you are right, I may be wrong. Maybe I am right, you may be wrong. So in both the cases, we have to consider, no. So we will be accepting this kind of small error, no. So this small error, which is in accepted range, that we call it as percentage error, and which may be available in all the cases. Next one is true value. True value. True value in the sense what we measure, no, that is what true value. Right. So by combining all these things, we are going to work on our today's problem. Right. நான் எதை வேணா யூஸ் பண்ணலாம், எனர்ஜி, பவர், கரண்ட், எப்படி வேணா போகலாம். ஸோ ஐ வுட் லைக் டு கோ வித் ஒன் பை ஒன். First, since we are a beginner, we will be starting with current. Right. Excuse me. Let me take a new board for us. Yes. So let me take small circuit for you all. ரொம்ப பெரிய சர்க்யூட்லாம் வேணாம். As we are a beginner, let us take a small circuit. So my circuit is this. Okay. Now I am connecting with the source. No, this let me take it as 100 volt. A DC source that I am connecting. So this is connected to two loads. Right? The loads are 80 kilo ohm and 20 kilo ohm. Right? And tell me the total resistance of this particular circuit. So I am connecting with two loads, namely load 1, load 2. Right. So now we are going to compute the total load connected with this source. Right. So this is what our first problem. A very, very basic one. Why I am taking this? And from here alone, we are going to lead our measurement. Because even though we are using the measuring instruments, that will have a small resistance in it. So which will have an impact. So that resistance which may be connected in series or it may be connected in parallel. So that will have a great impact. So first we should understand what is series connection, what is parallel connection. Right. So now this circuit I am going to consider and we are going to find the total load that I am connected with my source. Right. I give you a minute, please try to compute. Minute is too much here. Take a moment to compute the total load connected to the source. Sorry. So these two are connected in series, so directly, which means the connected load with the source is 100 kilo ohm. Now I would like to make a small change. I'd like to make a small change, which means the same circuit I'm just extending with yet another resistance. So the source is this. This is connected with not only with two resistance, the resistance which is already connected, no, that I am keeping it already. So let me directly extend with one more resistance like this. So this I would like to have it as one more 20k. Now you try to compute the total resistance connected to the source. So how do we compute? So first we need to compute the equivalent of these two because these two are connected in parallel. Find the equivalent of these two. What is the formula to connect? See, always I used to go with shortcut methods as we are the first people to learn this. So I would like to go with the direct measurement. 1 divided by R equivalent will be equal to 1 by R1 plus 1 by R2 plus and so on. So if you have any doubts or if you have any break or anything, please raise your hands. Now 1 by R equivalent. First let us compute this R equivalent, right, which is equal to, I have only two resistance, 1 by 20 plus 1 by 20. Both are in kilo ohms. So this is 20k plus 20k divided by 20k into 20k. Very simple. 20k plus 20k divided by 20 into 20k, which is 40k divided by 400k. 40k divided by 400k will be equal to 1 by R equivalent, which stands to your R equivalent as 400k divided by 40k. This is 10k. So the R equivalent of these two will be 10k. So when I take the total load connected to this circuit is, already we have 80k here and this R equivalent is 10k, so it will be 90k. So when I connect a resistor in parallel, which will decrease the load, right? Because the voltage will be dropped in both. The voltage is constant, the current which is dropped to both the load is distributed. If I have 10 amps, the load which is connected in parallel, no, which will be distributed. Now, this is not the role right now. Actually, our role is to find the true value. Find the true value. So, let us take the conditions for our understanding. Right. So, let me take it. Here comes, we are getting into the measurement. So, let us take the same circuit. So we have connected with 100 volt. So I have the same thing in my hand. That is 20 kilo ohm is connected, 80 kilo ohm is connected. Find the true value across 20 kilo ohm. True value across 20 kilo ohm. Because the voltage is dropped. Keep it in mind. Find the true value connected, sorry, across 20 kilo ohm. The voltage is dropped because these two are connected in series. You should keep it in mind. So these two are connected in series. Now find the true value across 20 kilo ohm. So let me make it for you. So direct voltage division, you know, right? Once again, I tell you the formula. Direct voltage division. As per the direct voltage division, the voltage across any resistor will be equal to the source that I am connected plus the source that I am connected plus the resistor I would like to measure, no, divided by my total resistance. Right? This is what the general formula. So we will be measuring like that. Right? We'll be measuring like that, and that is going to be, you see, what is the source connected? 100 volt plus what is the measuring value across 20 kilo ohm that we are going to measure, volt divided by total resistance will be sum of these two, 80 kilo ohm plus 20 kilo ohm. Now you find the value, just put it in calculator. Try to find the value. Right? It's a very easy one. 20 divided by 100 kilo ohm. So 100 kilo ohm, 100 will be cancelled. Right? You will get only the voltage. Kilo ohm will be cancelled. So you'll get only 20. Oh, sorry. Into, I made it as positive. So my source into resistance. So V is equal to IR. V is equal to IR. So I is your current. Here we are going with the source. So my true value in terms of voltage will be the source connected into my load connector. Right. So the source is 100 volt into 20 kilo ohm divided by 80 plus 20 kilo ohm. So this will be equivalent. So very simple one into 20 kilo ohm divided by 100 kilo. So 100 cancel, kilo ohm cancel. You will get only 20 volt. So now I just turn it. This we have measured across the true value measured across 20 kilo ohm. Now you try to find it across 80 kilo ohm. Very easy one. Just to repeat. You are going to change the value. That's all. 80 kilo ohm. Try to find it. Take a minute to find it. I hope you have done. Let me do it for you. So, as per the voltage division law, my source that is connected here is 100 volt into I would like to find it across 80 kilo ohm. So my measuring load is 80 kilo ohm divided by 80 plus 20. That is the total load I have connected. 80 plus 20 kilo ohm. Once again, you will get the value as 80 volt. Right. Now we are going to extend this. So you could able to measure the true value now. You could able to measure the true value now. Now I would like to extend. So let us take one gate questions for your further understanding. So the question here is a voltmeter of 0 to 100 volt has a sensitivity of 20 kilo ohm per volt, which is connected across 20 kilo ohm, as shown in figure. The same problem that I am taking, but there is a slight different. There is a slight different. So earlier cases, those who already know might have felt it like இந்த கொஸ்டின் என்ன அவ்வளோ பெரிய டிடிஎஸ் இருந்ததா. So that is what which will give you the lead to the particular problem. Right. So here it is shown. And what is the question? You see, sorry, a voltmeter of 0 to 100 volt has a sensitivity of 20 kilo ohm per volt is connected across 20 kilo ohm resistor, right, as shown in figure. Now what they have done, they are asking you the percentage error is dash. So percentage error is dash. That is what the question. Okay, the question is directly asked to you. Now, what is percentage error? First, we have to know what is percentage error. So for that, I would like to take the error first. Error தெரிஞ்சாதான் percentage கண்டுபிடிக்க முடியும். What is error? You see, actually my temperature is 98 degrees Celsius, but I measure it as 97 degrees Celsius. என்னுடைய டெம்பரேச்சர் 98 டிகிரி, பட் நான் மெஷர் பண்ணும்போது 97 தான் எனக்கு மெஷர்மெண்ட் வருது. அப்போ எரர் என்ன? மைனஸ் சப்ட்ராக்ஷன் பிட்வீன் யுவர் ட்ரூ வேல்யூ அண்ட் மெஷர்டு வேல்யூ. அவ்வளோதான் சார். இது ரெண்டுத்துக்கும் இருக்கிற டிஃப்ரென்ஸ் தான். பட் அந்த டிஃப்ரென்ஸ் ஹவு இட் இஸ் கோயிங் டு பி, தேர் வில் பி டூ டிஃப்ரென்ஸ், வெதர் ஐ ஆம் கெட்டிங் அடிஷ்னல் வேல்யூ ஆர் ஐ ஆம் கெட்டிங் a subtracted value. என்னுடைய actual value is 98 degrees Celsius. Excuse me. So actual temperature is 98 degree, right? I am measuring it as 97 degrees Celsius. அப்போ என்னுடைய டெம்பரேச்சர்லேருந்து இங்கே ஒன்று சப்ராக்ட் ஆகிருக்குதுன்னா வேல்யூ எப்படி இருக்கணும்? That should be one addition வேணும், which means -1. In the case, it is -1. But if it shows like 99 degrees Celsius, it is addition of 1, that is +1. அப்போ எப்படி இருக்கணும்? The value can be either positive or it can be negative. So what is error? The error is the direct measurement we are doing now, my measured value minus true value. This is what the difference. Measured value minus true value. Right. So now this is my error. Actually, what I need percentage error. What is percentage error? என்னுடைய percentage error எனக்கு 100 இருக்குது. Instead of 100, I am getting only 90, which means the error is 10%. How did you get this divided by 100? We are putting no. So the true value, we have to make it use of it. So what is percentage error? The measured value, all of you please listen, measured value minus true value divided by true value. So now what I need in this equation, look at here. I need percentage error. What is the true value? I should get the true value. என்னுடைய true value கண்டுபிடிக்கணும். Measured value also I should get. So first you find true value. Next you find the measured value and then go with the percentage. So how to find the true value? We all know in the previous in the previous so in the previous we have done it now how to measure the true value. So by using that you find it. How to find the true value? The true value is true value across 20 kilo ohm. What they have told, you see, voltmeter is connected, right? Connected across what? 20 kilo ohm. The true value should be measured across 20 kilo ohm, right? So find the true value across 20 kilo ohm. What is the connected source? 100 volt into 20 kilo ohm. Across 20 kilo ohm I'm going to find what is the total resistance. What is the total resistance? 80 plus 20 kilo ohm. Now, so this is not needed. I hope you understood that. So we are going to do with this, right? So this is what your true value. The true value which says you will get 20 volt. Now the true value is available. What is the next one? The measured value I am going to connect. How? What is the measured value? You see, here they have connected one voltmeter. They themselves told no. What they have told? They have connected one voltmeter. This voltmeter do have the range from 0 to 100 volt. 0 to 100 volt. But what is the sensitivity? What is the sensitivity? The sensitivity, the range is 0 to 100 volt, which means what is the sensitivity they have given? My sensitivity is 20 kilo ohm per volt. அப்போ ஒரு ஒரு வோல்ட்டுக்கும் ஒரு வோல்ட்டுக்கும் அது 20 கிலோ ஓம் சேஞ்சஸ் மேக் பண்ணும். In case if 20 kilo ohm is connected, I will be measuring it as 1 volt. That is what it means. எப்படி நான் சென்சிபிளா ஃபீல் பண்ணுவேன்? லைட்டா டச் பண்றது, it will not be much sensible. But if I slap you, It will be giving you more sense, So similar to that, the sensitivity is much more important. Now I am connecting one voltmeter. No, this voltmeter do have one inbuilt resistance. So the resistance of my voltmeter is also to be considered. That is what the hidden matter. That is what the hidden matter. In the previous problem, we have connected 20 kilo ohm directly and we found the equivalent resistor. Then we went on to the actual value, no, similar to that. Now we are going to do. But here the hidden factor is I have only the sensitivity. The sensitivity is 20 kilovolt, sorry, kilo ohm per volt. But what is the source I have connected? I have connected 100 volt. அப்போ என்னுடைய டோட்டல் ரெசிஸ்டன்ஸ் என்னவா இருக்கும்? The volt is cancelled. 20 into 1000. So you will get it like, sorry, 100. You will get it like 2000. 2000 kilovolt. So that is 2000 kilovolt, which you can also have it as 2 mega ohm. So what is the equivalent resistance here? It is 2 mega ohm. Now, when this 2 mega ohm is connected with this in Agom, the equivalent resistance will be the difference. This is what going to make the difference, or equivalent is what going to make the difference. Now you find R equivalent and then you go with your actual measurement, the measured value, or otherwise what we do, we will go like this. This will be easier to you maybe. So with that, we will have a small break. Please listen. Listen how it is being to be made. So my measured value is V measured. This is V true value. This is V measured value is the source which is equal to 100 volt into where I am measuring. I am measuring in this orange range, which means this simply mean that I have 20 kilo ohm and which is in parallel with 2 mega ohm. Please listen. So this is what the actually measured value, right? The measured value is the resistance of both. Also, a 20 kilo ohm in parallel with 2 mega ohm, and this is connected with 80 kilo ohm. 80 kilo ohm. Right. You know how to find the parallel resistance? The first problem I told you, 20 kilo ohm is connected with another 20 kilo ohm. Find the equivalent. No? So similarly, please try to find the equivalent. Just try to find the equivalent. I will give you the value. So anyhow, I will give you the value, but please you do it on your own. Try to find it on your own. Yes, I hope you would have calculated. Let me release the results. So when you take the equivalent resistance, if two resistors like 20 kilo ohm and 20 mega ohm are connected in parallel, the value will be around 19980. Not exactly, as I said, there may be a small deviation, so that we have to consider. So this may be equal to this. Similarly, the denominator may be equal to why? Because this is in mega ohm, we are in parallel with the 20 kilo ohm. So once again, we are getting the same parallel connection in the denominator as well, which is added with 80 kilo ohm. So this will be once again maybe equal to 99980. So if you take the total value, if you take the total value, like which is multiplied with the source, no, if you take it, it will be around. So actually, the 100 volt into the ratio of these two will be around 0.19. So somewhere around 98 or from 80 to 90. The last fractional value, this may differs to you based on the calculation you are taking with respect to your fractional load, no. So it may differs, right? So it will be around 19 point. So somewhere around 19 point. This fractional value may be 8 or it sometimes it may be 9. So here we will be facing the problem only when it is asked in terms of filling the blanks. Filling the blanks like கேட்கும்போது மட்டும்தான் exact fractional values நீங்க மைண்ட் பண்ணணும். Or otherwise they will be giving you the options ABCD கொடுத்துருந்தாங்கன்னா you can easily pick it out. So this fractional load will not you disturb much if it is objective type questions. So I got it around 19.98. So one time I got it around 19.84. So my range I am giving. So this is in between 19.98. 84 to 98. One of my students got it as 19.84 and one of my students got it as 19.98 in between. Right. So let me go with the first one. The first one. Right. Now this is my measured value. So what is our goal? Our objective is to find the percentage error. As I said, my objective is to find the percentage error. So what is percentage error? Measured value minus true value divided by true value, which is equal to 19.84 minus 20 divided by 20. So I need to find it in terms of percentage, So you have to multiply the same with respect to 100 to get it in terms of percentage. Right? If you go, it will be around, put it in calculator and find it. So the value is exactly the same. minus 0.8 in terms of percentage. So let me repeat for you. If you have lost at some point, please follow now. You may get it. So how we have proceeded till now. So that is what I'm going to discuss right now. Look at here. We have taken a circuit, a small circuit. So I have taken a small circuit. First, I have taken this as a small circuit. You see. So in this circuit, so here in this circuit, you see, we have measured our equivalent resistance first. In this small circuit, we have measured our equivalent resistance first, and which I have extended to additional load, so that you will understand both series load as well as parallel load. We have understood both. So how to find the equivalent resistance that we have calculated for this parallel load. So the equivalent resistor we have found, and from here what we have done, we have moved to the next range. Apo, when I have a circuit like that, how to find the true value, how to find the measured value. ரெண்டுத்தையும் கண்டுபிடிக்கிறதுக்கு we went with finding the true value, right? The true value, how to find it? You have connected with the source, and what is the resistance you will be considering to measure your value, no? That is what you have to consider in your numerator, and you have to consider the total resistance in your denominator. That is the formula. So for this 20 ohm, we found the true value first. So here in this case, so this is simply which will give you the understanding about how to find it. So in the next problem, they have given, no, this is the actual gate problem. In this gate problem, they have taken a circuit. In this circuit, they connected with a multimeter. So that multimeter, maybe in terms of voltage, we need to measure. No, the range is 0 to 100 volt. On range கொடுத்துட்டாங்க. அதோட sensitivity is also given. So from the sensitivity for the respective connected source, what could be the resistance of that particular meter? We have to find. So resistance வந்துருச்சு. So this voltmeter do have 2 mega ohm resistance. So we have to find the calculation between these two, that is the equivalent resistance across these two. அப்போ இதுக்கு ஈக்குவலன்ட் ரெசிஸ்டன்ஸ் கண்டுபிடிச்சு அந்த ஈக்குவலன்ட் ரெசிஸ்டன்ஸுக்கு வாட் இஸ் த மெஷர்டு வேல்யூ வி ஹாவ் டு கோ வென் திஸ் வோல்ட்மீட்டர் இஸ் நாட் கனெக்டட் வாட் இஸ் த actual value we will be measuring across 20 kilo ohm we have to find. So this is true value, and the next one is measured value, and by using those two we found the error, and from the error we found the percentage error, right? This is how we have to make. This is one problem. It may be, it seems to be tedious, but if you do it on your own you can easily find it. Okay, so take a minute break, not more than that. Just take a minute break. So meanwhile, let me make two questions for you. Do not take much more. ஒரு நிமிஷம் break வேணா போயிட்டு வந்துருங்க. So meanwhile, let me make your questions. Yeah. And if you please read the question carefully, we have taken 2 minutes, more than 2 minutes actually. So I have taken two questions and let me have the options are in common. So options are in common. Let us go. Try to find the answer on your own. The first question, the first question, the pressure gauge is calibrated from 0 to 50 kilonewton per meter square. It has a uniform scale with 100 scale divisions. The gauge has a dash. The following information. Right. So now let us directly take it. So for the first, that is the third question actually. Let me have this as my gauge, a pressure gauge for understanding. The scale is between 0 to 50. The scale is between 0 to 50. How many divisions I do have? I do have 100 divisions. So this is what the problem we solved at the beginning. By using ammeter, I had certain number of divisions for the range between 0 to 5 amps. So that I have given you the smallest value, that is the resolution what given in the first example. Now they are asking you to find not only resolution, that is the problem. They are given four options. In the first one, the dead zone. Second one, resolution. Third one, threshold. They have given three options. And the மூணு ஆப்ஷன்லயும் மீனிங் தெரிஞ்சிருக்கணும். The dead zone. See, I am making my step from this point to this point. This is the smallest step I am making. If I don't sense at all, I'll be standing here. I may sense, but the sensing will not be sufficient to me to move from this point to this point. இதுதான் மேட்டர். இங்க இருந்து எனக்கு இங்க மூவ் பண்றதுக்கு எனக்கு ஒரு மினிமல் ஃபோர்ஸ் வேணும். A minimal force is needed. Minimum time is needed. Minimum temperature is needed. So if I don't move at all, I'll be taking it as it's a dead zone. 0 to 20 milliamps. No, 4 to 20 milliamps. What is this? From 0 to 4. It is not that I will not be sensing. If I am sensing 4, I will be reading it as 0. If I am sensing 0, I am called as dead. அதுதான் அந்த மாதிரி தான் minimal force which helps you to get the first step reading, no? So that we call it as dead zone. The minimum value that I am sensing, no, that I call it as resolution. Similarly, I may move, but I will consider only after this particular point. So that is what threshold. So my scaling will have the deviation. This is my division. So my scale, my needle may stand at here, but I cannot read it. No, எனக்கு எப்போ ரீடிங் எடுக்க முடியும்? எனக்கு ஒரு பாயிண்ட்டுக்கு மேல தான் ரீடிங் எடுக்க முடியும். right? The threshold value is the boundary I will be considering. இங்கிருந்து இது வரைக்கும் நான் என்ன கன்சிடர் பண்ணுவேன்? I'll be considering only it as 0. When I cross this threshold value, I will be considering it as 0.1, 0.2, 0.3 and all, no? So that is what threshold. So these are all the smallest understanding we have to make. Now for the given statement, see, do not assume anything beyond the given statement. Assume only the given statement. The given statement is 0 to 50 kilonewton per meter square is what your range. That is 0 to 50 kilonewton per meter square is what given. How many number of scales given? 100 scale divisions are given. Now, my 50 kilonewton per meter square divided by 100 divisions are given, which means I'll be taking it as 0.5 kilonewton. Every division is telling 0.5 kilonewton per meter square. According to the smallest resolution, 0.5 சொல்லியாச்சு. So this is true. When it is true, this is false. Right? So dead zone, again 0.5 kilonewton per meter square இருந்தால் தான் confusions வரும். So it is 0.2. So this is also false. And threshold value, if it is 0.5 also, you will be confused. This is not 0.5, this is 0.1. So for the first question, option B is the right answer. Now what they have done? The second question, ஒரு சின்னதா மாத்திட்டாங்க. என்ன மாத்திருக்காங்கன்னு பார்ப்போம். They have the same 0 to 50 kilonewton per meter square range. How many divisions? 100 divisions. How many divisions? 100 divisions. அப்போ எனக்கு எப்படி சொல்லியிருக்கிறாங்க? Division 1, Division 2. But 1/5 of the scale division can be read with certainty. அப்போ எனக்கு ஒரு டிவிஷனுக்குள்ளேயும் 1/5, that means ஒவ்வொரு டிவிஷனுக்குள்ளேயும் என்ன சொல்லிட்டாங்க? They are having 5 subdivisions. அதுதான் ப்ராப்ளம். அப்போ longer reading, shorter reading, we have to consider both together. இப்போ சொல்லுங்க, what will be the resolution? The resolution will be sorry, actual reading is 50 kilonewton per meter square all divided by my scale with subdivisions of 5. So 50 divided by 100 into 5. What will happen in this case? 5 cancel, 0 cancel. 1 divided by 10 is equal to 0.1 kilonewton per meter square. Now what is the resolution? This is the resolution for your second question. So when the resolution fails, this fails. And this fails. And threshold value. This is not the threshold value. This is the resolution. They haven't mentioned anything relevant to threshold value, so this fails. Right? Same question. Just one additional information is diverted your entire resolution. This is what the additional information. So we should be very, very careful while making your sentence. Okay, good. So let us go with the next one. So this is the time to learn a new formula. A wattmeter having a range of 1000 watts as an error plus or minus 2 percentage of full scale deflection. அதான் மேட்டர். என்னோட டோட்டல் ஸ்கேல்ல இருந்து எனக்கு 2% டிஃப்ளெக்ஷன் வரும். ரைட். ஸோ இஃப் த ட்ரூ பவர் ஆஃப் 400 வாட் இஸ் மெஷர்ட், வாட் வுட் பி த பர்சன்டேஜ் லிமிட்டிங் எரர்? என்ன சொல்லியிருக்கிறாங்கன்னா 1000 வாட்ஸ்க்கு எனக்கு 2% எரர் வரும். விச் மீன்ஸ் வாட் இஸ் ஈக்குவலண்ட் ஆஃப் 1000 2% எவ்வளவு? இட் இஸ் 20. அப்போ நான் மெஷர்டு வேல்யூவே 40னா என்னுடைய எரர் எவ்வளோ இருக்கும்? சி கேர்ஃபுல் ஹியர். Do not directly go with the same 2%. Full scale deflectionக்கு தான் 2%. This is not full scale deflection. This is a limiting error. Right? எனக்கு என்ன ஆயிடுச்சு? I'll draw it to explain you the same. Sorry. Look at here. What they are telling. This is my full scale. Full scale values என்ன சொல்லியிருக்கிறாங்க? This takes 1000 watts. 1000 watts. 1000 wattsல என்னுடைய ஸ்கேலிங் எரர் ப்ளஸ் ஆர் மைனஸ் 2% ஒன்லி ஃபார் ஃபுல் ஸ்கேல். ஜீரோவில் இருக்கும்போது இட் வில் பி ஜீரோ. ரைட். ஃபுல் ஸ்கேல் வரும்போது எனக்கு ப்ளஸ் ஆர் மைனஸ் 2% இருக்கும். பட் வாட் ஐ எம் ஆக்சுவலி மெஷரிங் இஸ் 400 வாட்ஸ். அப்படி மெஷர் பண்ணும்போது என்னுடைய எரர் எவ்வளோ இருக்கும்? பர்சன்டேஜ் லிமிட்டிங் எரர். வாட் இஸ் மை பர்சன்டேஜ் லிமிட்டிங் எரர்? தட் இஸ் வாட் த கொஸ்டின். Right. So take down the available informations. Right. The givens are full scale value. What is the full scale value? Full scale value is given as 1000 watts to you. So let me take 1000 watts. Second one, full scale deflection. The error, a general error. Right. So my total error, I can have it as full scale deflection error will be equal to plus or minus 2%, which is also given. This is the related to accuracy. Right? This is related to accuracy, which we can also have it as guaranteed error னு சொல்லுவாங்க. எனக்கு full scale deflectionல இருக்கும்போது I'll get 2% error. Guaranteed error னு சொல்லுவாங்க. Right? Sometimes they call it as. No worry. Next one. What is given? My true power is given. Actual power is given. That is 400 watts. Now we know what is the error. இப்போ என்னுடைய எரர் 0 to 1000க்கு 2% இருக்குன்னா 0 to 1000க்கு 2% இருக்குன்னா carefully check in here. 0 to 1000 2% இருக்குன்னா deflection only up to 400. Only up to 400. So 1000 divided by 400க்கு 1000ல 400க்கு எவ்வளோ இருக்கும்? 1000 divided by 400க்கு எவ்வளோ இருக்கும்? ரைட்டுங்களா? That is what your percentage limiting error formula. This formula is general. Right? So this general formula is full scale value divided by true power, that is true value, into guaranteed error சொன்னோம் இல்லைங்களா? guaranteed accuracy related error, no, that I have to consider. Guaranteed error or guaranteed accuracy error. In both the cases they can represent. It's up to us, right? So we have to make our calculation. Now, is it only 2%? This is actually plus or minus 2%. We should include because they have given it as plus or minus 2%. If you directly go with 2%, plus 2% will be considered, not the minus 2%. So we have to consider everything. கேட்ல ரொம்ப ரொம்ப கேர்ஃபுல்லா இருக்கணும். We should be very very confident. We should be very very cautious. Right? Now, what is the value you will be making? 400 into 1000, which is 2.5 into 2%, both in terms of positive as well as negative 2%. So this will be equal to 2.5 plus 2 percentage and multiply பண்ணும்போது I'll get 5 plus 5 percentage minus 2 ஓட multiply பண்ணும்போது I will get minus 5 percentage. So plus or minus 5 percentage will be the reading. Right? Carefully check in. They are asking in terms of percentage limiting error. Percentage limiting error. So on reading in the 5%. That is 400 watts in the 5%. Not for full scale value. Full scale deviation. Carefully checking. The full scale deviation is directly it is 2%, but the reading what you are taking is only 400 watt. And the 400 watt plus or minus 5% error may be there. That is what you should be very, very confident. Don't confuse. Okay. Please make a note of it. Note பண்ணிக்கங்க. Okay. So let us go with the next question. So now I hope you are all much more confident about measuring your current, power, and voltage, true value, measured value, right? Even in terms of percentage. For a simple circuit, we have done, not for the big circuit. Okay. Now we are little bit confident about some of the informations. அதை வந்து repeat பண்ணுவோம். Already தெரிஞ்ச விஷயங்கள் ஒரு new additional information I need to add. Okay. So I have two resistance, namely R1, which is equal to 100, and my R2, which is also equal to, which is 50, and are connected in parallel. In a series, no, easier. You can directly add them. So these two resistors are connected in parallel. Find the total resistance. Find the total resistance. So what is the total resistance? We'll directly put it in parallel, no? Very simple one. Actually, we'll take it like my R equivalent will be R1 into R2 divided by R1 plus R2 100 into 50 divided by 100 plus 50 equal to, I hope you got this. Now, I'm not going to leave it as it is. I'm going to add one constraint to you all. That constraint is, so when I measure the resistance may be finding it in terms of ohms you consider, no worry. I'm not giving it with respect to units. In terms of ohms you consider, this you know it can be K or so. I'm taking a similar units to each other. Let us assume. But I have a error in both. I have error in both. So that too, you be careful. 2 percentage in 100 ohm is not equal to 1 percentage in 50 ohm, but the vice versa is same. 1 percentage in 100 ohm is equal to 2 percentage in 50 ohm. அதுதான் விஷயம். அங்கதான் கன்ஃபியூஸ் ஆயிடுவோம். Careful, be careful about this. 2 percentage in 100 ohm is not equal to 1 percentage in 50 ohm, but 1 percentage in 100 ohm is equal to 2 percentage in 50 ohm. So that is what the difference. Now, find the total resistance. இப்போ மேட்டர் என்னன்னா, I know the value. I should also give with respect to the error. அப்போ எரருக்கும் நான் கண்டுபிடிக்கணும். I should also consider the change in my resistance, error in my resistance. So first, R total is, R equivalent is same, 33.33, which is same. So you go as per your logical thing. Or logically, எப்படி நம்ம error identify பண்ணுவோமோ, you go as per that. You try to find it. Let us do with respect to our logical method, and then I would like to give you the easiest method as well. ரெண்டுத்தையுமே try பண்ணுவோம். If time permits, we will try to solve few more problems. Okay. So first, I found the total resistance. That is okay. Now I need to find the error. Error கண்டுபிடிக்கணும். First, let me take R1. What is R1? 100 plus or minus 2 percentage, which is equal to 2 percentage value எடுங்க. 100 2 percentage. Now, what will be the equivalent value? 100 plus or minus 2. So, what will be your R1? Therefore, my R1 will be 100 minus 2, which is 98, to 100 plus 2, which is 102. அப்போ மினிமம் வேல்யூ நான் என்ன கண்டுபிடிப்பேன்? 98 கண்டுபிடிப்பேன். மேக்ஸிமம் வேல்யூ என்ன கண்டுபிடிப்பேன்? 102 கண்டுபிடிப்பேன். Similarly, I have to put it for my R2 as well. R2 என்ன? 50 plus or minus 1 percentage. 50 க்கு 1 percentage is equal to what? 50 க்கு 1 percentage, which is equal to 0.5. 50 க்கு 1 percentage is equal to 1 percentage in sense what? 1 divided by 100. 1 divided by 100 is equal to 50 divided by 100 is equal to 0.5. So that is equal to 50 plus or minus 0.5. So that is equal to 49.5 இருக்கலாம். 50.5 இருக்கலாம். அப்போ I have two values, namely the lower value and the higher value. Now I am going to proceed. அப்போ எனக்கு மெஷர்டு வேல்யூவில் என்ன டீவியேஷன் இருக்கணும்னு நான் கண்டுபிடிக்கணும். Now go with the measured value. Measured வேல்யூவில் நான் என்ன பண்ண போகிறேன்? I am going with the lowest measured value. What will be the lowest measured value? Lowest measured value of my resistance R equivalent will be equal to 98 into 49.5 divided by 98 plus 49.5. I hope you understand, which is very simple. That is R1 plus R1 into R2 divided by R1 plus R2. அது என்னுடைய smallest value, that is smallest measurement நான் first equivalent கண்டுபிடிக்கிறேன். Find the equivalent of those. Try to get the value. Similarly, try to get the R equivalent of the highest value. Highest value க்கு R equivalent போட்டா என்ன வரும்? The values are 102 cross 50.5 divided by 102 plus 50.5. Right. So this is equal to what? What is the equivalent? So it will be around 32.88. Right. Similarly, for this, .33 sorry, yeah, 33.77. 33.77. This is 32.88. No, it's time to find the percentage. Look at here. This we have to make it like my R equivalent plus or minus error percentage. We got the error. We found the error. Error கண்டுபிடிச்சிருக்கோம். எப்படி error கண்டுபிடிக்கலாம்? How to find the percentage error? The error is equal to measured value minus actual value divided by actual value, or true value divided by true value, whatever it is. In the similar case, I have to find it now. What is the measured value? 32.88 minus 33.33. அதான true value. Actual value என்ன? இதுதானே. This is my true value divided by 33.33. So if I put it in this case, this is minus, so I will get it around minus 1.3. The similar case, I leave it to you to find it for the maximum value. Maximum value கண்டுபிடிக்கிறதுக்கு நான் உங்ககிட்டயே கொடுக்குறேன். Find it and give it to me. Don't take much time. Less than a minute. Less than a minute. Yes. When it is minus 1.3, this will be plus 1.3 in terms of percentage. In terms of percentage. So what will be your actual R equivalent now? My R equivalent will be 33.33 plus or minus 1.3 percentage. So this is how we need to find the total resistance. So is it the only method? Should I calculate the value? Should I find the percentage with respect to that particular identification? Should I go? ரொம்ப tedious-ஆ இருக்கிற மாதிரி இருக்கும். It will be a bit tedious, okay? So for that, I have a combined method. ரெண்டுத்தையும் கனெக்ட் பண்ணி ப்ரொசீட் பண்ணிக்கலாம். Okay, let me give it to you. The combination of both. So this is the shortcut method. You can take it. So we are going to do it together. So let me do it in terms of violet for you. So my R equivalent, I am going to find the R equivalent, which will be equal to R1 into R2 divided by R1 plus R2. R1 plus R2. Right. So what is your R equivalent? First go with the R1. Go with the R1. That is 100 plus or minus 2 percentage into 100 plus or minus 2 percentage into 50 plus or minus 1 percentage. I am taking the error along with me. அங்கே தனித்தனியாக பண்ணோம், இங்கே சேர்த்து பண்ணுறோம், அவ்வளோதான் டிஃப்ரென்ஸ். ஸோ ஹியர் ஐ நீட் டு டூ த அடிஷன் 100 plus or minus 2 percentage, addition plus or minus 2 percentage plus 50 plus or minus 1 percentage. Numerator multiplication, denominator addition. So to find the total value. So here we will be confusing. We'll be confusing. Can I directly add in terms of percentage? You cannot. You cannot directly add in terms of percentage. So for that I will give you the clue. A small clue எடுத்துக்கங்க. When, let me make it as a smallest note for you. Okay. Whenever it is needed, we will take it. Okay. So here you consider when both are in yellow. Sorry. It is given in terms of percentage. Error percentage கொடுத்திருந்தாங்கன்னா, and if the operation is multiplication, you directly perform addition. If the operations are division, you directly perform subtraction. But when the operations are addition subtraction, we cannot do multiplication division. We have to do it with value. So need to go with values. Okay, this is the hint for you. So let me give this hint again. Let us keep this hint somewhere else. I'm sorry. So let us keep it away. Now, so have this hint for you. Let us proceed. So what is here? Here, the errors are given in percentage and it is in multiplication. So what I need to perform? I need to perform addition between these two. Now, 100 plus 50, sorry, into 50 is equal to 5,000. When I multiply, the total value will be 5,000. Here, the plus or minus. I need to perform addition. When it is multiplication, I need to perform addition. So if this is in multiplication, so perform addition plus or minus 3 percentage. Whole divided by, right. So what is here? Here in division, in denominator, it is in addition. When it is in addition, what I need to do? I need to convert it into value and then I should add them. So convert it into value 100 plus or minus 2 percentage for my 100 is equal to 2. So let me make it as 2 directly. Plus similarly for 50 plus or minus 1 percentage, that 1 percentage is going to be 0.5. So plus or minus 0.5. Now you can add them. You can add them. 5,000 plus or minus 3 percentage divided by add them 100 plus 50 is equal to 150 plus or minus, add these two, which is 2.5. In numerator, it is in percentage. In denominator, it is in value. Be careful here. In denominator, it is in value. Now, what we have to do? We have to convert this denominator value into percentage. Right? We have to convert this value into percentage. When I convert this 150 ki 2.5 percentage, sorry, 2.5 value, that is 2.5 divided by 150, you will get around 0.016 and all. So when you do calculations, so this will be equivalent to 5,000 plus or minus 3 percentage whole divided by 150 plus or minus 1.67 percentage. 1.67 percentage. Now we do our divisions. 5,000 divided by 150 is equal to something around 33.33 and so on, plus or minus, plus or minus 3 percentage divided by 1.67 percentage. When it is in subtraction, it's supposed to be, sorry, when it is in division, it's supposed to be subtracted. That is what the hint given. When it is in division, we supposed to take it in terms of subtraction. So 3 minus 1.67 is equal to 1.33 and so on. Is equal to 1.33 and so on percentage. So you could find that the identification of this is same as this. This is the combined method. In the previous one, we have separated. Lower limit தனியா எடுத்தோம், upper limit தனியா எடுத்தோம். ரெண்டுத்துக்கும் we found the error, we found the percentage, and we made it into attached to our original equivalent value. இங்க என்ன பண்ணிட்டோம்? We have taken our true value along with the error what we get. In consideration, we have taken both together. Okay, ma? Good. It may be bit tedious to understand. Or problem practice பண்ணிக்கணும் போது it will be easier. The percentage is the most beautiful concept which will be induced in your gates. Okay. Last 5 minutes, please quickly make a note. ஒரு குட்டி ப்ராப்ளம் சால்வ் பண்ணிட்டு க்ளோஸ் பண்ணிக்கலாம். டைரக்டாக ஃபார்முலா கொடுத்துட்ற அந்த ப்ராப்ளத்துக்கு டைரக்டாக ஐடியா சொல்லிடுறேன். I'll take a minute. Then if there are any queries, let me answer them, then we will wind up. Okay. Okay, I hope you copied. Or otherwise, the details will be circulated to you all. எப்போ வேணுமே ரெஃபர் பண்ணிக்கோங்க. So very easy one, this one. I'll give you the formula alone. So we need to find the power. எதுக்காக அப்படின்னா this percentage will have an impact. I told you no. So earlier cases also we have taken our percentage into our account. So here we know how to find the power. Power is equal to VI. So direct away true value you can find it. That is 100 into 50 which will be equal to 5000. Power கண்டுபிடிச்சிட்டோம். இங்க they are not asking the error, they are asking the standard deviation to be included. The error are in standard deviation, so we have to find the standard deviation. Standard deviation we know that the square root of your variance. எரருங்கிறது என்ன, என்னுடைய ட்ரூ வேல்யூல இருக்கிற வேரியன்ட் எவ்வளவு வேரி ஆகுதோ அதுதான் என்னுடைய எரர். ஸோ யூ டைரக்ட்லி கோ வித் த ஸ்கொயர் ரூட் ஆஃப் யுவர் error. Square root of error, we take it like what is your P? P is equal to VI from the formula. I have only one voltage, one current. So one voltage, that voltage error I should consider 2 plus one current, that current error I should consider. So as I said, that is square root of a square plus b square. Similarly, here in this variance square, in this value variance square. The variance are, here it is 2, it is 1. So if it is like v square I, if the formula is like v square I, power formula kadayadu, understanding I am telling, if it is v square I, this will be 2 into 2 whole square. ஓகேங்களா. now if you directly apply square root of 4 plus 1 which will be equal to square root of 5%. So this 5% variant, the standard deviation is what? Error. The errors are given in standard deviation. அப்ப என்ன பண்ணணும், என்னுடைய actual power value ஓட this plus or minus square root of 5% add. Right. So this errors you should not leave it at any cost at any point. ஜஸ்ட் ஒரு சிம்பிள் மேக்ஸ் தான், நமக்கு ஆல்ரெடி தெரிஞ்ச மேக்ஸ் தான், நம்ம மிஸ் பண்ணாம we have to adapt those mathematics along with us when we do the calculation. Right. Okay, with that note, let us conclude our session, today's session. So if there are any doubts, you can raise your hands.